So, today, we're going to pull back the curtain on one of the coolest secrets in all of artificial intelligence: how a computer actually learns to see. We're talking about the very first step it takes to understand any image you throw at it. You've seen it a million times, right? You upload a photo and instantly your phone or social media puts little boxes around everyone's faces. How does it do that? I mean, it feels like straight-up magic, but it's not. It's a really clever process that starts with something surprisingly simple. You'd probably guess it starts by looking for eyes or maybe a nose or a mouth. Nope. The reality is way more fundamental. Before a computer can even dream of finding a face or a car or your cat, it has to learn to see the most basic thing imaginable: the simple lines and borders that make up every object. It all starts by just finding the edges.
All right, so let's really dig in. What does it actually mean for a computer to see? We're going to break down that very first step.
See, a computer doesn't try to swallow the whole image at once. That's just too much information. Instead, it uses a kind of divide and conquer strategy. It might start by just scanning the entire picture for only the vertical lines. Then it'll do another pass, this time looking for only the horizontal lines, like the edge of this railing here. It breaks a complex world down into simple patterns.
Okay, but how does it actually do that? How does it just find the vertical lines and ignore everything else? Well, for that, it needs a special tool and a very specific process. And to get it, we need to meet two key players: filters and convolution. First up, the tool. It's called a filter, or you might hear it called a kernel. The absolute best way to think about a filter is like a tiny, custom-made magnifying glass. But here's the cool part. Instead of just making things bigger, this magnifying glass is designed to light up only when it spots the one specific pattern it's built to find.
And here it is. This is what one of those filters actually looks like in the wild. It's a little 3x3 grid of numbers, and this specific one is designed to find vertical edges. Just look at the pattern for a sec. You've got a column of positive ones, a column of zeros, and a column of negative ones. That simple arrangement, that's the whole secret.
So we have this cool little pattern detector. Now what? Well, we basically just slide it over every single little piece of an image, one spot at a time. This systematic process of sliding and calculating has a fancy name: convolution. It sounds complicated, I know, but as you're about to see, it's really just simple, repetitive math.
So let's get our hands dirty and see this thing in action, step by step. I promise, the math behind it is way easier than it sounds.
So here's our test image. Now, remember, to a computer, there are no colors, no shapes, just a grid of numbers. This is a simple 6x6 image where each number just represents how bright a single pixel is. We're going to run our filter over this.
The whole process boils down to just 4 simple steps. Super straightforward. First, you place the filter on a little patch of the image. Then, you multiply the matching numbers together. Third, you add all those little results up into one single number. And finally, you just do it again and again and again. Let's do the first one together. Okay, here we go. First step, we take our little filter and we lay it right on top of that top left corner of the image, covering those first 9 pixels. And now for the math part. We just multiply each number in the filter by the pixel right under it. Add them all up, and boom, we get -5. That number becomes the very first pixel in our new transformed image. And then what? You guessed it. We just slide the filter one little spot to the right and do the exact same thing all over again.
Place, multiply, and sum. This time, we get -4. That becomes the second pixel in our output. It's like an assembly line, right? We just keep it moving, sliding, and calculating across the whole image.
And once we've slid that filter over every possible spot, we're left with this: a brand new grid of numbers. Now, this isn't just random math. This is what we call a feature map. You can think of it like a treasure map, where the big numbers are the X's marking the spots where the computer thinks it found a vertical edge. Okay, so we've done the math, we see what it does, but why? Why on earth does this weird little grid of ones, zeros, and negative ones find vertical edges? This is the aha moment. To really see the magic, let's use a perfect, super simple image. Imagine it's bright on the left, dark on the right, a perfect vertical edge right down the middle. Now watch what happens when our filter slides over it. The output is almost all zeros, except for this one bright, glowing line of high numbers right where the edge was. It found it, loud and clear.
And that really gets to the heart of it. The filter is just a little machine built to find one single pattern, a place in the image where there's a sharp change from bright pixels on the left to dark pixels on the right. To a computer, that is the definition of a vertical edge.
So really, all it is a little pattern detector. When the part of the image it's looking at perfectly matches its internal pattern, bright on the left, dark on the right, bam, it activates and spits out a big number. If the pattern doesn't match at all, it just stays quiet and outputs a 0 or a small number. It really is that simple.
So why are we spending all this time on one little math trick? Because this simple process, this thing called convolution, it's not just a trick. It's one of the absolute core, fundamental building blocks of all modern computer vision and artificial intelligence.
All right, let's wrap this up and put a bow on it. What have we really learned here? Well, we've seen that computers use this process called convolution. They use these things called filters, which are basically just tiny pattern detectors. They start simple, by finding basic features like edges, and use those to build up a complex picture of the world. And this whole mechanism, it's the engine inside what we call convolutional neural networks, or CNNs, which are the powerhouses behind nearly all modern AI vision. And that leaves us with one final big idea to chew on. We've just been looking at one tiny filter designed to find one simple thing, a vertical line. Now just imagine what a computer could learn to see if it used hundreds or even thousands of different filters all at the same time. Maybe one for curves, another for corners, one that loves the texture of fur, another that only activates for the color green. When you start combining all of those, you don't just get edge detection anymore. You get the very beginnings of sight itself.